Hi, I'm Staff Sergeant Matt and I'm an Apache pilot in 663 Squadron at Army Air Corps.
The Apache helicopter isn't just any war machine, it's a flying tank that can survive brutal attacks and unleash massive destruction. Day or night, rain or shine, this terrifying beast locks onto its targets with deadly precision. But what makes it so fearsome on the battlefield? Let's dive into the mechanics behind this ultimate weapon. At first glance, the Apache might seem like just another helicopter, but beneath its sleek exterior lies a machine engineered for war. The Apache's main rotor, with its four 20-foot blades, isn't just for show. It's the muscle that lifts this beast into the sky. The pilot, using a swashplate mechanism, can tweak each blade's tilt to control lift and maneuver the helicopter with incredible precision. When the blades tilt in sync, the Apache rises or descends straight up and down. But when the pitch changes as the blades rotate, it creates uneven lift, tilting the helicopter to fly in any direction. But that's just the beginning. The main rotor's spin creates a rotational force that would send the entire helicopter spinning, if not for the rear rotor blades. These double-tail rotors work against the spin, keeping the helicopter stable or allowing the pilot to rotate it at will. Powering this flying tank are twin General Electric T700-GE-701C turboshaft engines, each packing around 1,700 horsepower. The engine's power is transferred through a gearbox and transmission, driving both the main rotor and tail rotor with precision. The rotor blades themselves are a marvel of engineering, made with stainless steel spars, a fiberglass skeleton, and titanium edges strong enough to brush off minor obstacles during low-altitude flights. This nap-of-the-earth flying is crucial for sneaking up on targets and avoiding enemy fire. Hellfire missiles. Now, the Apache helicopter's chief function is to take out heavily armored ground targets like tanks and bunkers with ruthless efficiency. But to achieve that, you need more than just raw firepower. You need precision. And that's where the Hellfire missile comes in. This isn't just any missile, it's a miniaturized aircraft armed with a high-explosive, copper-lined charge warhead capable of burning through even the toughest tank armor. These missiles aren't just strapped on for the ride. The Apache carries up to 16 Hellfire missiles on 4 firing rails attached to pylons mounted under its wings, 2 pylons on each side. Before launching, each missile gets detailed instructions from the helicopter's computer. When it's time to strike, the computer sends the fire signal, and the missile ignites its propellant, generating about 500 pounds of force to break free from the rail. As it accelerates, the missile arms itself, ready to unleash devastation upon impact. Originally, the Hellfire missile was guided by a laser system. The Apache gunner would aim a high-intensity laser beam at the target, pulsing in a unique coded pattern. The missile's nose is equipped with a laser seeker that locks onto the reflected laser light from the target. As the missile flies, its guidance system constantly adjusts its course using flight fins, much like how an airplane steers. This method is incredibly precise, but has its vulnerabilities. If clouds or obstacles block the laser beam, the missile can lose its target. And for the laser to stay locked, the helicopter or ground forces must remain exposed, risking enemy fire. Rockets and chain gun. Apaches often switch out 2 of their Hellfire missiles for Hydra rocket launchers, giving them extra firepower for a range of missions. Each rocket launcher carries 19 folding fin, 2.75-inch aerial rockets, locked and loaded in launching tubes. When it's time to fire, the launcher ignites the rocket from the rear of the tube, and once the rocket is airborne, its fins unfold to keep it on a stable path toward its target. The Apache gunner has the flexibility to fire rockets one by one or unleash them in groups, depending on the situation. These rockets can be outfitted with various warheads tailored to the mission at hand. From high-explosive warheads to smoke-producing payloads, the versatility is impressive. Some rockets even carry submunitions, miniature bombs that scatter from the main rocket in mid-air, raining destruction on targets below. For close-range combat, it packs an M230 30mm automatic cannon mounted under its nose. Controlled by a sophisticated computer system in the cockpit, this cannon is a chain gun design, driven by an electric motor that powers the loading, firing, and ejection process. Unlike typical machine guns that rely on the force of the explosion to cycle the bolt, the M230's chain system ensures a relentless rate of fire. The magazine above the gun holds up to 200 rounds, feeding them through a chute into the chamber. With the capability to fire 600 to 650 rounds per minute, this cannon delivers high explosive rounds that can shred through light armor. Controls. The Apache's cockpit is a dual setup, with the pilot stationed in the rear and the co-pilot gunner up front. The pilot handles the flight, while the gunner takes charge of the weapons. But in a high-stakes situation, both can swap roles seamlessly, thanks to dual flight and firing controls in each section. Flying the Apache involves using collective and cyclic controls, much like those in other helicopters. These controls work through a mix of mechanical hydraulics and a digital stabilization system. The digital system plays a crucial role, refining the hydraulics to ensure smooth flight and even enabling the helicopter to hover automatically for short bursts. In the Longbow Apache model, 3 digital display panels replace traditional dials, giving the pilot a clear, streamlined view of navigation and flight data. With just a few button presses, the pilot can access all the vital information needed to navigate and control this formidable machine. Sensors. One of the most impressive features of the Apache Longbow is its cutting-edge sensor technology. At the core of this system is a radar dome mounted on the mast, sending out millimeter waves that reveal the shape of everything within its range. This data is analyzed by a radar signal processor which cross-references the shapes with a comprehensive database of tanks, trucks, aircraft, and other equipment. The results are then pinpointed on the pilot's and gunner's display panels, making target identification both swift and accurate. Evasion tactics and armor. The Apache's first line of defense is to stay out of harm's way. Built to skim low over the ground, it hides behind cover whenever possible, making it a ghostly presence on the battlefield. Its radar-evading design helps it slip past enemy scanners, and if the pilots detect radar signals, they can deploy a radar jammer to create confusion. But evading radar is just part of the strategy. The Apache also shields itself from heat-seeking missiles by minimizing its infrared signature. The black hole infrared suppression system cools engine exhaust by blending it with surrounding air, and a special filter absorbs additional heat. To further protect against heat-seeking threats, the Longbow is equipped with an infrared jammer that disrupts missile guidance with varied infrared frequencies. Armor is another crucial defense. The Apache is heavily fortified, with Kevlar soft armor providing extra protection in key areas. The cockpit is encased in reinforced armor and bulletproof glass. Boeing boasts that the helicopter can withstand hits from 12.7mm rounds and that critical components can endure 23mm fire. In a crash, the cockpit's design acts like crumple zones in a car, absorbing impact forces to protect the crew. The pilot and gunner seats are fitted with heavy Kevlar armor to further cushion the blow. Thanks to these advanced systems, the crew has a solid chance of surviving even the toughest situations. That wraps up our look at the Apache helicopter. What intrigued you the most? Drop your thoughts below and don't forget to check out the video popping up on your screen now.